Hello learners. In today's lesson we're going to be looking at trigonometry, and we are doing basic trigonometry. So I'll be telling you everything that you need to know about trigonometry and then giving you all those basics so that you can start answering your questions. So before we start with the lesson, please like, share and subscribe to the channel so that you get more of this content. With all that being said, let's get right down to the lesson. So starting off, we have the cast diagram. We are told that the cast diagram helps us to see which quadrants the trig ratios are positive. So remember, we have here the first quadrant, which we know in the first quadrant, we say all the trig ratios are positive. Remember, the trig ratios we are dealing with are your cos, sine, and tan. So here they're all positive between the angle 0 to 90 degrees, right? Then in the second quadrant, it is only sine that is positive, right? Between the angles 90 to 180 degrees, right? So we have sine being positive there, but cos and tan are negative. Then in the third quadrant, between 180 and 270 degrees, we have tan being positive, but sine and cos are negative. Then the fourth quadrant here, we have cos being positive and sine and tan are negative, right? So this is between the angle 270 and 360 degrees. So this is the first quadrant between 0 to 90, and the second quadrant is between 90 to 180. Then the third quadrant is between 180 to 270. Then the fourth quadrant is between 270 and 360, right? Now let's check what is going on here. So again, this is another cast diagram that is clarifying all that I said. So you can see there the first quadrant between 0 to 90 degrees, sine is positive, cos is positive, tan is positive. In the second quadrant between 90 to 180, sine is positive, but cos is negative and tan is negative. In the third quadrant, sine is negative, cos is negative, but tan is positive. Then fourth quadrant between 270 and 360, sine is negative, cos is positive, but tan is negative, right? Now you can see that if we can look at this, let's see the relationship of the cast diagram and the graphs of your sine, cos, and tan, right? So remember, for sine, we said sine is positive in the first quadrant because all trig ratios are positive in the first quadrant, but then it is also positive in the second quadrant, right? As you can see here, from 0 to 90, this indicates the first quadrant. Then from 90 to 180, this indicates the second quadrant. We can see the graph of sine here is above the x-axis to show us that sine is positive in the first and second quadrant. But let's see what is happening between 180 to 270. We know that this is the third quadrant, right? In the third quadrant, what is happening to our sine? Our sine is below the x-axis to show us that it is negative, right? Then between 270 and 360, we can see the graph is also below the x-axis. That indicates that sine is negative in the fourth quadrant. Now let's look at tan. Cos. Let's look at cos between 0 to 90 degrees. What do we see? We see the graph is above the x-axis. Remember, cos is positive in the first quadrant because all trig ratios are positive there. Then in the second quadrant, cos is negative. We can see that it is below the x-axis, and also on the third quadrant, it is below the x-axis. So cos is negative there. But let's check between 270 and 360 what is happening. Your cos graph is now above the x-axis to indicate that it is positive there. So remember, cos graph is positive in the first and the fourth quadrant, and then sine graph is positive in the first and the second quadrant. then it's negative here, right? So negative, negative. Then that's how we have it. Now let's look at tan. Tan, we know it's positive, so between 0 to 90 degrees, we can see that tan is positive there, so the graph is above the x-axis. But then tan is negative in the second quadrant between 90 to 180, so we can see the graph starts all the way below there, and then it's negative. But then from 180 all the way to 270, we can see the graph is now above the x-axis. What do we know about tan in the third quadrant? Tan is positive in the third quadrant. But then again in the fourth quadrant, what is happening to your tan graph? It goes back below the x-axis to indicate that in the fourth quadrant it is negative, right? So all this, the cast diagram is in agreement with the graphs, right, that we have for your sine, cos, and tan, right? So that's it. Let's proceed. So now let's come to understanding the reduction formulae, right? So we have the reduction formulae. In this case, we'll be taking our reduction formulae in an anti-clockwise direction. That means this will be our initial, and we'll only be calculating the angle from the x-axis here. So we'll be calculating the angles from the x-axis and then to that direction, right? So that's the anti-clockwise direction. And then we can see here it's still indicating that all trig ratios are positive greater than 0. And then here only sine is positive, only tan is positive, and only cos is positive. Remember, greater than 0 means positive. Then what are they saying here? For first quadrant, if an angle is in the first quadrant, its value is between 0 to 90 degrees. So we know we've already stated that. So in other words, we can say in the first quadrant, that's where we have 90 degrees minus theta. So that's the reduction angle that we have there, right? Or the reduction formulae that we have in the first quadrant. But then in the second quadrant, what do we have? Remember, it's from 90 degrees to 180 degrees, right? So in the second quadrant, we have 90 degrees plus theta, and also 180 degrees minus theta. So we are simply saying the angles are between 90 to 180, right? So in between, right? So in between 90 to 108. But then in the third quadrant, what do we have? From third quadrant, that's greater than 180, so it's 180 plus theta, right? But then we also have another one. Remember, here we have 270, so this will be 270 degrees minus theta, right? So but then remember, when we are using our reduction formulas, we are mostly advised that we shouldn't use the 270 as our reduction formulae, as the 270 also is a cofunction, right? But then for grade 11 and 12, 10, 11, 12, we don't use that reduction 270. Instead, we use only the cofunctions of 90, right? So for the fourth quadrant, what do we have? That 270 degrees plus theta. Also, again, you don't have to use this one. Then the one that is acceptable for the fourth quadrant would have to be 360 degrees minus theta, right? So now let's check. So let's look at this. We have the second quadrant here, so our reduction formulas are indicating here the second quadrant. So remember, when we are in the second quadrant, how will we say that we are in the second quadrant? By this reduction formula, 180 degrees minus theta. So whenever you see the reduction formula 180 degrees minus theta, then we know we are in the second quadrant. Now this is how we deal with this. We say, how is sine in the second quadrant? So sine in the second quadrant, we say it is positive. Hence this one reduces to sine theta. Then we have cos 180 degrees minus theta. That's what is cos in the second quadrant. Cos is negative in the second quadrant, so it reduces to negative cos theta. And then what about tan? How is tan in the second quadrant? So tan is negative, it reduces to negative tan theta, right? So this is how you deal with this. And then when you see that 180 plus theta, we know that it's in the third quadrant. So basically all this that I've written here indicates your quadrants, right? So 180 degrees plus theta indicates the third quadrant. And again, we can see that the only trig ratio that is positive in the third quadrant is tan, and sine and cos are negative. Then we have the fourth quadrant. The fourth quadrant is indicated by the reduction formulae 360 degrees minus theta. So how is sine in the fourth quadrant? We know that it is negative, so it reduces to negative sine theta. And then cos is the one that is positive in the fourth quadrant, so it reduces to positive cos theta. And our tan once again reduces to negative tan theta in the fourth quadrant, right? But then here there is a note. They say when using 90 degrees and 270, the ratios are changed to their core ratios or core functions, right? So we call this core functions. The core ratios of sine theta is cos theta. The examples are in the first quadrant. If you have sine 90 degrees minus theta, so how do we know this is in the first quadrant? Because of that reduction formulae, 90 degrees minus theta. So if you have sine 90 degrees minus theta, this reduces to cos theta. That is to say, for example, if we have cos 90 degrees minus 50 degrees, that means our solution is equals to sine 50 degrees. Now you will realize that sine and cos are complementary ratios, right? What does that mean? It means that if we are considering between the angles being in the first quadrant and the second quadrant, if we have, for example, cos 40 is equals to sine 50. Now complementary, remember, means that it adds to 90 degrees. If you can look at this 40 added to that 50, you can see that we have 90 degrees. If, for example, we have cos 30, we know cos 30 will be the same as sine 60. So as long as the angles that we have here add up to 90 degrees, we say they are cofunctions, right? Then in the second quadrant, what do we have? For the second quadrant, we have sine 90 degrees plus theta. So we know that it's in the second quadrant because of that reduction formulae, 90 degrees plus theta, as you can see there. I've indicated in the second quadrant. Then when that reduces, it reduces to its cofunction, which is now positive cos theta. So the way you deal with this is you ask yourself, how is sine in the second quadrant? So sine in the second quadrant is positive, therefore its cofunction or core ratio will also be positive. But then when we get to cos, how is cos in the second quadrant? We can see that cos in the second quadrant is negative, right? So therefore its core ratio or core function will become negative sine theta, right? So you always refer to the parent here, right? So how is cos in the second quadrant? It is negative, hence we have negative sine theta. But how is sine in the second quadrant? It is positive, hence we have positive cos theta, right? Then also other cofunctions are your 270 minus theta. They also act the same as your 90 minus theta and 90 plus theta. But then for the level in grade 10, 11, 12, we don't get to use these ones. So when you are studying, please avoid using these ones, or when you are answering questions, please avoid using the reduction formulas for 270, right? Okay, so if we have this right angle triangle here, we can use it to write our trig ratios. So we know for our trig ratios, we have saw, car, toy, whereby we know this implies that sine is equals to opposite of a hypotenuse, and this is cos is adjacent of a hypotenuse, and tan is opposite over adjacent. So as we can see here, it is indicated sine theta opposite of a hypotenuse, cos theta adjacent over hypotenuse, tan theta opposite over adjacent. Now we can also express this in terms of y, x, and r, whereby if we know that our opposite moves along the y-axis, so that's y, and then our adjacent moves along the x-axis, so that becomes x, and then our hypotenuse, we can indicate our hypotenuse as r, right? So let's put r here. Then having to express our sine theta, we know that for sine theta we will have sine is equals to opposite, the opposite being y, over the hypotenuse r, and then that's sine theta. Then for cos theta, we will have adjacent, which is x, over the hypotenuse r, and then for tan theta, we will have opposite, which is y, over the adjacent, which is x. So we can express it in that form, in the form of y, r, and x. Now coming to these ones here, if you are in grade 10, you know in grade 10 we used to do this, and then whereby we have cosec, sec, and cot. So these are the inverses of your sine, cos, and tan. This is how you find out or you memorize that. So if we write cosec, this is cosec in full, this is cosecant, then you just count here and find that letter. So if you have cos, this is C-O-S, and then since you have S here, that letter, you know this will be an inverse of sine, so that becomes 1 over sine theta, right? Then having to look at sec, secant, so you have sec, if you count here 1, 2, 3, that letter, that indicates that your sec theta will be an inverse of cos, right? So from C here in the dead letter, we know that will be an inverse of cos. And then we have the last one, which is cot, right? Which we can see from writing that cot theta, the dead letter there is T, so that becomes the inverse of tan. That's 1 over tan theta. And that's how we have it. Now to show this, we can see this is sine theta opposite of a hypotenuse, which is what we basically spoke about. And then also this is all that we spoke about. And then note that if we have a missing side here, since we say this is a right angle triangle, if we have a missing side, we can calculate it using the Pythagoras theorem. Remember, Pythagoras theorem is only applicable for right angle triangles. So if we have our r here, which is an unknown, and it happens that our y is 4, and then our adjacent is 3. Now if we want to calculate this side, the hypotenuse, we can use our Pythagoras theorem, which we know all the way from grade 9. It goes as r squared is equals to x squared plus y squared, right? Then our x being 3 square plus y, that's 4 square, and then if you just punch all that, 3 square, that becomes 9, 4 square, that becomes 16. Then what is 9 plus 16? That gives us 25. And then if you can just root both sides here, you will have your r is equal to 5, right? So that's how you have it. You have r is equal to 5, and you would have calculated the missing side. Also, we know that we can use our Pythagoras to find the opposite side. So for that, you'd have y squared is equals to r squared minus x squared. Remember, hypotenuse is the longest side of the right angle triangle, so it has to be the one that we subtract from. Then if you're looking for x, you have x squared is equals to r squared minus y squared. So all those formulas come from the Pythagoras theorem. Then we have the trigonometric identities, which we know from grade 11. If we have our sine squared theta plus cos squared theta, it gives us 1. So that is to say, if you put any angle here, let's say maybe you have cos squared 30 degrees, and then you add it to sine squared 30 degrees, you would have 1, right? So if you consistently substitute in one angle here, you'll have that. But remember, in a calculator, you don't have this square coming after the trig ratio here. So in a calculator, it will be something like this: cos 30 square plus sine 30 square. So you have to know the difference in your calculator. That's how it will appear. Then we have another trig ratio again from grade 11, which is tan theta. Tan theta is equals to sine theta over cos theta. Now when you get to grade 12, you know this they might include a double angle on it, which is also true if you have two tan 2 theta, which is double angle of tan. This will also give you double angles there. So what you do with this side on this angle, you also have to do that side with the angles. So you have sine 2 theta over cos 2 theta. So that would be something that they give you in grade, right, with the double angles, of course. Then having this, we know we can also break this down further. Our cos squared x plus sine squared x equal to 1. Remember, if we want to make cos squared x the subject of the formula, we can have cos squared x and then transpose that to the other side. That gives us that. And then if we also want to have our sine squared x as the subject of the formula, we will have sine squared x is equals to 1 minus cos squared x. So that's basically what you have there on the table. So now let's come to using this right angle triangles to find the values to your special angles. So the idea with this question is that most of the time when you are given questions that relate to you finding the values of the special angle, the question will mostly say without the use of a calculator. In fact, most of the questions that are based on trigonometry always say without the use of a calculator. So now let's see how we get the values to the special angles 30 degrees, 45 degrees, and 60 degrees without the use of a calculator. So now in this case, you still apply the SOHCAHTOA. So let's see here. So we have SOHCAHTOA, which we know sine opposite of a hypotenuse, cos adjacent of a hypotenuse, and tan opposite over adjacent. So now let's say we were looking for sine 30 degrees, right? So for sine 30 degrees, we know we have opposite of a hypotenuse. So we'd come to this 30 here. If we have this 30 here, we say, what is the side that is opposite this 30 degree angle? So we can see that opposite that 30 degree angle, we have 1 unit, and then the hypotenuse is 2 units. So that means our sine 30 degrees would be 1 over 2, right? Then let's check if we wanted to calculate sine 45 degrees. So for sine 45 degrees, we obviously have to use this right angle triangle, this side, because it is the one that is isosceles. It has these two base angles equal, and then also the sides that are opposite those base angles are equal. So we have 1 unit, 1 unit, 45 degrees, 45 degrees, and we have our hypotenuse side as root 2 units, right? So these are the standard right angle triangles. You need to memorize them like this. You need to draw them exactly as they have given you here, right? So for sine 45 degrees, if you reference from any 45 degrees, we know the opposite of this 45 degree is 1 unit, and also the opposite of that 45 degree is 1 unit. So you can reference from any angle here. So that's sine 45 degrees 1 unit, and then over the hypotenuse, that's root 2. So that means your sine 45 degrees would give you sine 45 degrees would have 1 over root 2. But then remember, if you were to punch this in your calculator, it will give you root 2 over 2. Now, if you write this one, it would straight out tell the marker that you used the calculator. Now we know this one, this value here and that value, they are equal. How are they equal? Remember, in grade 10, we used to have this thing called rationalizing the denominator, right? Whereby we knew that if our denominator was in sad form, we needed to rationalize the denominator so that we don't have our denominator in sad form. So what you do to rationalize the denominator is that you'd multiply by that denominator root 2, but then immediately you'll have to divide by that root 2. Remember, this one comes out as if you have just multiplied by 1, right? So remember, root 2 and root 2 over root 2 is still 1, right? But then here we know mathematically we have manipulated something, because now we're going to say numerator multiplied by numerator and denominator multiplied by denominator. In that case, what is our solution? We'd have 1 times root 2. 1 times root 2, it will give us root 2. But then if we say root 2 multiplied by root 2, remember that would give us root 4, right? So square root of 2 times square root of 2, that would be 2 times 2 inside the square root, which will give us square root of 4. And then we know square root of 4 is equals to 2. So you can see that that value root 2 over 2 is still the same as 1 over root 2. But then this would be the one that you'd acquire using your right angle triangle, and this one would be the one that you get using your calculator. So make sure when it comes to sine 45 degrees, you write this one, 1 over root 2. Then we have sine 60 degrees. So for sine 60 degrees, this is what we have. For sine 60 degree, again using our Soccer, we know that it's opposite. So what's opposite to that 60 degree angle now? So we can see that opposite the 60 degree angle, we have the root 3 here, and then the hypotenuse is root 2. So our solution for sine 60 degree, root 3, and to say over 2, right? So that's root 3 over 2. Now you can also use the same thing, the Soccer to calculate the other trig ratios, right? So if we were looking for cos 30, we know that cos is adjacent of a hypotenuse, so we'd say cos 30, that's 30, what is adjacent to 30 degree? That's root 3, and then over the hypotenuse, that's 2, so hence we have root 3 over 2. And again, if we are looking for cos 45, what is adjacent to 45? It's 1, and then what's the hypotenuse? Root 2. So we have that 1 over root 2. And when we go to 60, what's adjacent to 60 degree? It's 1. And what's the hypotenuse? That's 2. So we have 1 over 2. Note that sine 45 and cos 45 are equal, because remember, sine and cos are co-ratios, right? So when their angles are complementary, they will always be equal. For example, if you can see here, sine 30 is equal to sine cos 30 degrees, because 30 and 60 are actual complementary angles. Then when we go to tan 30, what is tan 30? We say what is opposite to tan 30? It's 1, and then over the adjacent side, which is root 3, right? So we have 1 over root 3. But then when we go to 45, we say what is opposite of 45? It's 1, and then what's adjacent to 45? It's 1. So we have 1 over 1 giving us 1 unit. Tan 60 degrees. For tan 60 degrees, again here we have this is 60 degree, and then it's opposite. What's opposite to 60 degree? It's root 3, and then what's adjacent to that 60 degrees? 1 unit. So we have root 3 over 1, which will give us root 3. So this is how you get the angles using your right angle triangles. So you get those special angles, the values for those special angles. So in grade 12, we have what we call compound angles, which are as follows. You have your sine A plus B, that gives you sine A cos B plus cos A sine B. And then you have your cos A plus B, which gives you cos A cos B minus sine A sine B. And then your sine A minus B, that's sine A cos B minus cos A sine B. And then your cos A minus B, that's your cos A cos B plus sine A sine B. Now, if you want to see the trend in this, maybe for the purpose of knowing and memorizing this, you can see what is happening with sine here, the trig ratio sign. So if you have sine, you have it being sine A cos B, and the sign inside here doesn't change. So this is a positive, it still remains positive here. Then you have cos having the angle A, and then sine having the angle B, right? So it's more like they swap around the angles here. So you can see sine had the angle A initially, and then cos had the angle B, but then now this side causes the angle A and sine has angle B. So you can see that also happens with this one, sine A minus B. This is sine having the first angle A, and then cos having the second angle B. But then when you skip over with the sine being the same, that's a minus and a minus, we have cos having the first angle now, and sine having the second angle, right? So, but then with cos, what is happening with cos? It will have the first angle and the second angle before it gives the angles to the trig ratio sign. And then what do you notice also? There is a change in the sign here. So from plus, we have now a minus sign. And then from minus, we now have a plus sign. But then no need to memorize this because it will be given in your formula sheet, right? So it will always be provided in your formula sheet. Then what you need to know is that you can use one of these compound angles to derive the formula for other compound angles. For example, you have questions like that. Let's say they say given. The questions might appear in this form. They say given that for example cos A minus B is equals to cos A cos B plus, remember the cos changes the sign, and then is equals to sine A sine B sine B. Now they would ask you to calculate or derive the equation or expression for cos A plus B, right? For cos A plus B. So now they want you to have this one, cos A plus B, but they only gave you this one, right? So now how do you ensure that you get to that one? So it's just a matter of coming here and using what you are given here so that you can have that. So this is what we'll do. We'll say, because you can see that here we have negative B and then here we have positive B. So we have to think of a way to make that negative B become a positive B, right? So without having to change this. So this is what we'll get here. So we'll say let B equals to negative B, right? So let where there is B now so we have that A minus, then remember let B be negative B, so where there is B I'll now substitute negative B. So I haven't changed the form is still in the form of A minus B. But then what did I do? I just manipulated this B so that it becomes negative. Now what am I aiming for here? What is the purpose of me doing this? I want this negative outside here to multiply with this negative so that it gives me the positive that I see here. So now having to continue with this one, I will write it exactly as it is here, and then this is cos A. Remember, I did not tamper with A, but then I did tamper with B. I said now let B be negative B, right? Then I have plus, and then this is sine A. I did not tamper with my A, but I tampered with B, so this is sine negative b, right? Now, having to continue with this, we know that here what we're gonna have is now cos a, then since we have that negative and negative, now it's plus b. So you can see that now I have this expression here, right? Now let's continue with the question. Now I have cos a, but then remember, cos of a negative angle, we always say cos of a negative angle is positive. So we have positive cos b, right? Then this side here, we have plus sine a, but then we know sine of a negative angle, that gives us negative sine b, right? That gives us negative sine b, because sine of a negative angle is always negative, right? Then what do we have for this one? So now we have cos a plus b, and then this is gonna give us cos a cos b, but then remember, this positive times negative now gives us a negative. So we have negative sine a and sine b and sine b. Now you can see that we've deduced the expression or derived the expression for cos a plus b. Let's check it out. So look, this is cos a minus b. This goes cos a cos b plus sine a sine b. But then we needed to take this one and form that one. So let's check. This is cos a plus b. That gave us cos a cos b minus sine a sine b, which is exactly what we have here. Cos a cos b minus sine a sine b. Now you can note this. You can note this, the negative angles. So know your negative angles. Your negative angles. So we said sine of a negative angle will always come out as negative sine theta. And then cos of a negative angle is the only trig ratio that comes out as a positive. So you can even test it in your calculator. Just put a negative now, a negative angle, and then it will just give you that positive number. Then we have tan of a negative angle, that will give us a negative value, right? So negative tan theta. So those are your negative angles and what they produce. Okay, so we also have the double angles, which now we can see that we have 2 sine 2 alpha, which gives us 2 sine alpha cos alpha. And then remember that the alpha can go from alpha to beta to theta, right? So you can use any angle here. They can even use x, but then the double angles are still true. These double angle identities are still true, right? For any angle that you put in there, right? Then we also have this one for cos double angle. So this is cos 2 alpha, which will give us cos squared alpha minus sine squared alpha, which can also be written as 2 cos squared alpha minus 1, and also 1 minus 2 sine squared alpha. So I'll be showing you how we get to this part, how we get to the part whereby we have this 2 cos squared alpha minus 1, and also this 1 minus 2 sine squared alpha, using this one, right, that we have. So the standard formula, or the standard double angle identity, is cos 2 alpha, which we have seen it gives us cos squared alpha minus sine squared alpha. But again, if we have to consider the grade 11 identity, which goes cos squared alpha plus sine squared alpha is equals to 1. Now we know that if we want to make for example, our cos squared x, the subject of the formula. So we'd have cos squared alpha, so let's say alpha, 1 minus sine squared 1 minus sine squared alpha. And again, we said if we wanted to make sine squared alpha the subject of the formula, we'd have sine squared alpha, which is 1 minus cos squared alpha, right? So at this point, if we want to derive this one here, if we want to have this one, then we can just express this in the form of, so we can just convert or write this one in that trig identity, right? So we have sine squared alpha, which will give us 1 minus cos squared alpha. So this is how we'll have it. So just substitute that. So this is y is equals to cos squared alpha. Then in the position of sine squared alpha, I put what? 1 minus cos squared alpha, right? So what is it that I'm going to have now? That's cos squared alpha. Then a negative times that negative 1 gives me a negative times that positive 1 gives me negative 1. And this negative times that negative gives me positive cos squared alpha. Now you can see that we have like terms here, and then they are both positive, meaning we can add them, right? Those are like terms. So now we have 2 cos squared alpha minus 1. So that's how we got to that one. Then let's check if we wanted to produce this one, 1 minus 2 sine squared alpha. This is what we'd have now. So again we have the standard, which is cos 2 alpha is equals to cos squared alpha minus sine squared alpha. But this time, because I'm looking to express this in terms of sine, I will have to change this cos into this trig identity here. So cos squared alpha, I know that it is equals to 1 minus sine squared alpha. Then minus this sine squared alpha. Now you can see that I have like terms in the same direction, the negative direction. So that means I can add them together. Then this is negative. This is 1 minus this is 1 minus 2 sine squared alpha, right? So that's how we have it. So that's 1 minus 2 sine squared alpha, which you can see translates to that. So that's how we have this. That's how we have those trig ratios. So, okay. Now let's come to this one. Let's say we wanted to derive how they got to this one. Sine 2 alpha is equal to 2 sine alpha cos alpha. Now you will note that we have a compound angle here. So let's look at the compound angles. We have this one that goes sine A plus B is equal to sine A cos B plus cos A sine B. So we can just manipulate that one. So first, let's write it. Let's write it out. So we have our sine A plus B, which gives us sine A cos B. Remember, the sign doesn't change. And then we have cos A and then sine B, right? So manipulating that one so that we have a double angle, we'd say let B be equal to A. So in this case, A and B will be equal angles. So if A is 30 degrees, that means B is also 30 degrees. Now that means we have sine and then A plus a, right? Remember we said let b be equals to a. So where there's b now, I'm going to substitute a. Wherever I see b, I'm now putting a. So sine a cos a, remember I see b, so I'm putting a. And then cos a, and then sine a. Now at this point you can see that for this side we have a plus a, which will now give us the double angle sine 2a, right? And then for this one you can see that if we can just rearrange it like this, so that you see that these are like terms, this is cos sine a cos a, and then we can, since they have the same angle, now we can write this as that sine a cos a. Now we can clearly see that these two terms are like terms, right? So sine a cos a, and also this term is sine a cos a. So what do we have now? Our solution for sine 2a. So now we have sine 2a is equals to 2. So we have sine 2a is equals to 2 sine a cos a, right? So this is how we have it. This is how we have it.